Good morning. So today I'm going to discuss about a numerical problem on gyroscope and gyroscopic couple. So please note down the problem. A ship is propelled by a turbine rotor which has a mass of 5000 kg. And a speed of 2100 rpm. This rotor is having a radius of gyration of 0.5 meter and it rotates in clockwise direction when viewed from the stern. Now you have to find out the gyroscopic effect on the following condition. So you have to find out the numerical values as well as you have to explain that the bow and the stern, they are having a tendency to move in which particular direction, in port side or in starboard side, or they should move upward or tilt downward. What is the condition that you have to explain accordingly. So the next half of the numerical problem is number A. When the ship sails at a speed of 30 km per hour, and it steers to left hand direction, having a curve of 60 meter radius. So when this type of steering is going on, you have to find out what is the gyroscopic value and the gyroscopic effect on that particular ship. This is part number 1. Second part, that is part B. The ship is pitching 6 degrees above and 6 degrees below the horizontal position. It is directly given that 6 degrees above and 6 degrees below the neutral or horizontal position. Okay? The bow is falling with maximum velocity. The bow is falling with maximum velocity. The motion due to pitching is simple harmonic in nature, and the time period is 20 seconds. Okay, so you have to find out in this part B that what is the gyroscopic couple, and you have to explain that in which particular direction the bow is tend to move, that is towards starboard or towards port, that you have to explain accordingly. And the third part, that is part C, the ship is rolling and at a certain instant it has an angular velocity of 0.03 radian per second clockwise when viewed from the start. That is omega p equal to 0.03 radian per second clockwise when viewed from the rear end, that is stern side. So you have to calculate and find out what is the gyroscopic couple value and what is the gyroscopic effect on the ship. So there are three different criteria that you have to calculate and explain accordingly. So one by one we are going to solve this problem with the given data. So first of all, when the ship steers to the left, that is, first we are going to explain the part number A of this particular problem. So here it is given that the velocity is 30 kilometer per hour. So this is equal to 30,000 divided by 3600 meter per second, or if we further simplify it, we are going to get this value is equal to 8.33 meter per second. Okay, and capital R, that is the radius of rotation, that also is given, that is equal to 60. Okay, so omega p in this case equal to 8.33 divided by 60, which is equal to if we calculate, we will get 0.14 radian per second. Okay, so from the given problem we know already that I, that is m into k square. So I value we are going to get 5,000 into 0.5 whole square. So I value, that is mass moment of inertia, that is 1250 kg meter square. Omega 2 pi by 60 into n, and n value it is given as 2100 rpm. So omega value we are going to get, if we calculate, we are going to get 220 radian per second. And obviously for this particular situation the omega p we are getting 0.14 radian per second. So the gyroscopic couple value, that is capital G, which is nothing but I omega p, if we calculate, then 1250 I into omega 220 into omega p, this is 0.14. So if you calculate, you will get the answer as 38,500 Newton meter. The answer will be 38,500 Newton meter or 38.5 kilonewton meter. So this is your answer. This is one part of this numerical problem. Now, what is main important criteria for this particular problem, that you have to explain that while it is taking a certain type of movement or motion, for example, here it is given that it is steering to the left hand direction and the bow is actually, let me check, oh okay, so it is taking a left hand direction, so we have to check and verify that what is the nature or tendency of the bow is falling or bow is rising. So for that, what we are going to do, we have to draw a circle just like this, and here we have to mention that first of all that this particular intersection over here, it is actually the main shaft axis of this particular vessel, of this particular sheet. So this is the propeller. Okay, it is indicating the propeller. Now over here it is moving in the anti-clockwise direction. So when it is moving in the anti-clockwise direction, so the directional arrowhead, it should look like this. Okay. Now what they are asking, the bow is falling or the bow is rising? It is taking a left hand turn or it is taking a right hand turn? It is taking a left hand turn. Now we know very well that it is moving in the anti-clockwise direction. Which one is moving in the anti-clockwise direction? That particular propeller is moving in the anti-clockwise direction when viewed from the stern side. So when it is viewed from the stern side, then that particular, what we are getting when it is taking a left hand turn, so this left hand side is for left hand turn. So what is the tendency of the bow? This top half is the bow half. And the bottom half is for stern. So the bottom half is for stern. So over here we can see the top half and left hand turn. So this particular quadrant or this particular quarter is given as the idea that from here to here the bow is actually falling. So when this ship is taking the left hand turn, the bow will fall with maximum velocity when this ship is taking a left hand turn. So that includes everything. So the first part is the calculation, numerical calculation, and the second part, if you draw the thing like that and if you conclude the thing with this diagram, then it includes each and every detail. Okay. Now we are moving towards the second part. So in the second part, we know that phi equal to 6 degree, that is 0.105 radian per second. Time period 20 seconds, it is already given, that we know. And omega p, okay, so omega p equal to, we know very well, that is that includes 2 pi by time period. So if we calculate, we will get this value 0.3142 radian per second. Okay, sorry, it is not omega p, it is actually omega 1. Just hold on a minute. This one is the omega 1. So we are getting the concept of omega 1 like that, and omega p, that is omega 1 into phi, that is equal to 0.3142 multiplied by phi value, which is 0.105 radian per second. So if you just multiply them, you will get the answer, that is 0.033 radian per second. Okay, so this is the value of omega p. Now, maximum gyroscopic couple. What is the value of maximum gyroscopic couple? That is, sorry, G equal to I omega p. So already we know what is the value of I, that is 1250, omega, that is 220 radian per second. So 1250 220 radian per second, and omega p it is equal to 0.033. Now we move towards the third part, that is when it is rolling. So during the rolling operation, it is given that the omega p value that is equal to 0.03 radian per second. So when that happens, we know very well that directly we can write down gyroscopic couple equal to I omega p, that is 1250, that is I into omega 220 into omega p, that is 0.03. So directly we can find out the value which is equal to this much, 8250 Newton meter. So this is the value that we can calculate and we can find out easily. But the thing is that what is the tendency of rotation of the particular vessel? So you have to write down here the axis of spin and axis of precession are parallel to each other. They are not making any surface in between. So because they are not making any surface in between, what is the surface? The surface of the gyroscopic plane. So they are not making any surface of the gyroscopic plane. So there would not be any effect of gyroscopic couple. So that concludes everything, because there are not a particular surface is being created of the active gyroscopic couple. So there will be no effect of this gyroscopic couple on that particular case, of that particular vessel. Okay, so like that you can continue with other numerical problems of the similar type, where the data might be different but the technique are the same. Only the thing you have to remember that whether during the pitching, during the steering, the rotor of the ship is rotating in clockwise direction or anti-clockwise direction with respect to the viewer who is standing behind the stern. So that concludes this numerical problem. Thank you very much.